yeah, really briefly, A-Cloud Guru, we're an online learning company. One of our sort of unique differentiators is we've deployed our entire platform using serverless architecture. We don't have an entire server in our environment. So we're really going to talk about that. And just for Ian, everything's going to be in Comic Sans, because that's what he asked. So yeah, the question is the future of cloud serverless? Yeah, my name's Stanley. That's find me on Twitter. I can't promise anything educational in my tweet stream, but yeah, you can follow me anyway. So Norm mentioned a URL you need to go to if you want to get free access to any of our courses. Also, if you want to win any of these, you need to sign up, because we'll be doing a draw based on who signed up. Go to this URL, b.acloud.guru/now. So if you go to that URL, so go back a little bit. So at reInvent, Werner on the second day went through the 6 laws of architecture. He referenced academics over the years who had done a lot of thinking around distributed computing and social theory, and he kind of used that as an intro. So we're going to try and do the same thing and kind of bring quotes from academics and that who thought about things way before cloud was even invented. So the concept I want to start with ephemeralisation. So this is a concept from the 1930s, a guy called Buckminster Fuller. But essentially it comes down to this. It's the ability to do more with less and less until eventually you can do everything with nothing. And that we see with AWS. It's gone from EC2 to Lambda. EC2 you're deploying on a per hour basis. Lambda you're deploying on a per 100 millisecond basis. So to go back to the sign up, so what would have happened today, to give you an example of how this works, is you would have gone to that b.acloud.guru URL. It's hosted within the URL itself. We use Route 53. It then points to an S3 bucket with static website hosting, which we've got a redirect on that redirects you to a service called Typeform, an independent service. Once you've filled in the URL, you've hit enter, this process happens. So what happens is you go to Zapier. Unfortunately, that's the only integration Typeform have is Zapier. They don't have webhooks or anything like that. Go to Zapier. Zapier, unfortunately, polls every 5 minutes. It's not live, it's not Lambda, it's not API Gateway, unfortunately. So every 5 minutes, so if you sign in, you put your details in, every 5 minutes is polling Typeform, and then sends that information to a Lambda function. From that Lambda function, we're writing it to DynamoDB. It then triggers another function using DynamoDB streams, which then we integrate with another platform called Campaign Monitor. Campaign Monitor has a function called transactional emails. It's a little bit like SES, except they're a lot prettier and nicer, and we get a lot more analytics out of it, which is why we use them. I've had some fun and games with the DynamoDB streams today. AWS say they're like database triggers. They are absolutely nothing like database triggers. So if you're a DBA, don't expect to use DynamoDB streams. It's a stream, like a Kinesis stream. So it's not a trigger, despite what Jeff Barr says in his blogs. So once you've signed up, we'll have sent another email. We send dynamic information through to Campaign Monitor. Then you can go to our website. You go to our website, you sign in with, we use a platform called Auth0 for authentication. Once you sign in with that platform, it will redirect you to, it'll pass that information via a token that then signs you up via intercom. Once that data hits intercom, there's a webhook which talks to API Gateway, which talks to Lambda, which writes back to that same DynamoDB. So we've got a record of who's signed up, and then who's got the email, and who's actually gone through and signed up. So we kind of closed the loop. There's a little secret in this. So the actual bit where we draw and we decide, there's no ability to randomly select a DynamoDB record. So those records are numbered, so we're actually going to do a physical draw and pull out the number. But we'll ignore that. And I ran out of time. So the main thing is, in creating this process, I started on Monday. Absolutely no servers were harmed in the making of this process. We don't particularly like servers anymore. So it took about 8 hours to write, of which about 5 were debugging. Yeah, asynchronous JavaScript is not fun. Yeah, so yeah, nothing was provisioned. We just wrote code. That's the brilliance of Lambda. You just write code. So on to the second law. Schumpeter's Gale. Oh, gone a bit too fast. Schumpeter's Gale. It's also called a process of creative destruction. So essentially, a process of improvements is the process of, what should I say? Yeah. The process of industrial mutation will consistently create new value, but then also consistently destroy that value with the high order processes created on top of that. So think of the EC2 to Lambda. Lambda's built in EC2. EC2 8 years ago was awesome. Now it's boring and no one really wants to, well, you guys probably do, but we really don't want to worry about EC2. So let's look at how things evolve. Traditional architectures, three-tier architecture. You've got your client tier at the top, you've got some sort of monolithic middle tier, and then you've got a data storage tier at the bottom. From a modeling perspective, so typically you'd have a user interface that's referencing variables that have been, this client-side model binding that goes to a service layer that integrates with with your logic tier, your application logic tier, which also has another service layer, apply your business logic, then there's a data integration layer, talks to your business logic. So that's kind of what it looks like these days. So that's your typical traditional three-tier architecture. We're moving to serverless, you're moving to microservices. This all changes. First of all, you start doing a lot more integration at the client. PCs are really powerful these days. Phones are really powerful these days. All our client devices are really powerful, except for maybe your IoT device. They're slightly different. So you don't want to do integration in IoT on your client, but outside of that. So we do some sort of integration on our client, data transformation and wrangling, and do a lot of business logic on the client. We then call external authentication services. We then have an external data storage services, multiple. And then all we do is we write our own little individual Lambda functions for the stuff that's unique to our application. We don't worry about writing authentication service because we're just consuming that from someone else. But in terms of a data storage service, we just write data, read data from someone else's service. We don't have to have a proxy or a database or anything. Someone else worries about that for us. We just have an API we talk to. So the model changes. The model changes to, you still have your user interface, and you still have those three layers, your client-side binding and your integration. But you're actually doing a lot more there than you were before. It's no longer a thin layer, it becomes more of a fat layer. And then you just have a database storage layer, a data persistence layer that you call via an API, and then your unique microservices on top of that. You can get products and applications to market significantly quicker if you adopt this kind of architectural style. And the key thing is that it's microservices. Every single service you create, there's one rule to it, is that you want it to do one thing and one thing well. With Lambda, what you're getting is you got these services that the term loosely coupled. They're not even loosely coupled, they're barely coupled. They're like strangers passing in the night. They do one thing and one thing well, and that's it. They don't need to know about anything else other than who they're getting data from and where they're putting that data to. Outside of that, you don't have to bind it to anything else. So let's go to the next one. This has actually been mentioned already today, Conways law. But essentially, Conways law says that organizations are constrained by their communication structures. In a simpler way, what that means from a tech perspective, so go slightly back. So Mel Conway, when he put this out in the early 90s, he submitted a paper to Harvard Business Review. It got rejected because he had done no testing of this theory he had. It was just a hypothesis, done zero testing. Subsequently, MIT and Harvard themselves have done a whole lot of testing. And what they found is that organizations that have large monolithic, large centralized application teams tend to write tightly coupled monolithic applications. And then they found organizations that had loosely coupled development teams, small loosely coupled teams tended to write loosely coupled services. So Amazon, for example, is a really good example of this. If you look at all the announcement, they'll always talk about the EC2 team and the ECS team and the DynamoDB team. Those are all small teams writing unique features. They don't talk to the other guys. They just know that whatever they write has to meet a certain set of criteria from an interface perspective. They actually don't really know what the other people are writing. One of the key bits about this, what people don't get, you want to adopt microservices, is you actually need to make an organizational change. Adopting all the tooling in the world isn't going to save you if you still got a team of 40, 50 developers sitting in a room together talking to each other each day. Because applications they write are going to look exactly like the way they communicate with themselves. Split them up, split your functions of the application up, split those teams up, and start writing applications that way. So that's kind of what we've done. in that respect. So we don't have lots of teams. We can't write an authentication service. So we use lots of third-party services that we call directly by an API. I'm drinking too much beer. So really some example, Auth0, authentication service. I'll go in a bit more detail about them, but instead of us writing integrations for Facebook and Google and all these social sign-ins and then having a native authentication, we utilize their SDKs and we integrate with them. Firebase, real-time streaming database, uses WebSockets. It's really, really cool because you don't need to have a DBA anymore. Firebase is a DBA. Ironically, Firebase is a bit of a strange one because they're owned by Google, but they run on AWS. Not that Google wants you to know that, but they only bought them in February, and Firebase is not going to be able to move to the Google infrastructure. Stripe's another one, Intercom's another one. So all standardized functions, we use third-party applications, and all the unique stuff we do ourselves, either by writing custom code on the client or any kind of private integrations where we don't want to share secrets, we do in the back end in Lambda. So a really good example would be a credit card payment. You go into our site, you put in your credit card, what happens is a Stripe pop-up will actually come in and ask you for your details, which is great. Stripe handles that whole payment. But what Stripe also does is on the back end is they'll make a call to us, to an API we present via API Gateway, and go back to us and say, hey, someone wants to make a payment for this amount of money for this service. Is it correct? Because if someone gets into that front-end code, they can in theory send incorrect information to, drop the price to 0 or something. What we do is then we validate that the information being sent to us from Stripe is the information we sent to the user making the payment. If it's not, we cancel the transaction. But we don't want to be sharing that information on the front end. So we do that on the back end. So this kind of architecture, you make decisions like where do you want that logic applied? You can apply it on the front end. Remember, there's lots of unused processing power there. Use that. Also, it'll give you a far better performance if you're doing a lot of that stuff on the front end. But you can't do everything on the front end. And that's where Lambda comes in. So another really good simple one as well is also Campaign Monitor, which I used earlier. So if you guys got emails saying this is what you've selected, click on this to get back into a website, it came via Campaign Monitor. You respond to our forum topics. Anyone within our platform has responded to a forum, or if you've asked a question on our forum, you will get emails back anytime someone responds. Now, we don't want to be piping all those emails through to your client, all the email addresses to your client browser to send that email from the client. We do that on the back end as well because we want to keep those emails private. So, fourth. So, Goldratt, he's quite famous for the theory of constraints. And he talks about utilizing a resource and activating a resource. Activating a resource to him is about turning a machine on. It provides absolutely no value until it's actually being utilized. So with traditional on-prem servers, we saw lots of activation, lots of servers turned on doing nothing, and utilization was really low. And what you get with these evolutionary steps is that the gap between utilization and activation is getting a lot smaller. So I'll give you an example of how we do that. We have a very high utilization model. We don't want to have resources sitting there doing nothing, which is why I use a lot of these services. So I'm going to talk through how authentication works quickly. We use Auth0. This is their website. If you go to our login, you'll come up with this page. This is an Auth0 page. Once that happens, so on the back end, when you configure Auth0, you can decide what integration you want. Really simple, really easy. It's ridiculous. Auth0 uses JSON Web Tokens for authentication. So essentially, when you authenticate with Auth0, you'll get a JSON Web Token. That JSON Web Token will get stored in your browser, and then we pass that around. It's used to identify yourself, and we use it to authorize access into particular services. So Auth0, what happens, you log in, you get your JSON Web Token. That JSON Web Token is actually stored in your browser. And then you want to make a call to Firebase, so you want to access a course. So Firebase checks, okay, is this user, by identifying them via the JSON Web Token, allowed to access that, and allows them access. But we use that for everything else. AWS supports JSON Web Tokens. So for S3, when you want to view a video, we use signed URLs, and we use the JSON Web Token to authenticate you. It's a really simple, easy process. If you want to build applications really quickly using something simple as Auth0 and JSON Web Tokens, you can really create like a really simple streaming service. And you can get that up in minutes, or not minutes, probably an hour or two. The other simple thing we do, so back in transcoding pipeline. So if you view a video and you've got all the options for HD and standard definition and the different sizes, what happens actually is those are multiple copies of that same video. It's not transcoded on the fly. Your backend provider, so we'll have multiple copies. So for us to do that, we actually have to transcode multiple copies. It's not like we're sitting on our laptops transcoding on one copy on our laptop and we can just on the fly change it down. We'll have I think we've got about 6 different versions of a particular video we'll store. So the way we do that is you put something to S3, Lambda picks it up, sends it to Elastic Transcoder service. Elastic Transcoder transcodes it into our 6 different versions we need, dumps it into another S3 bucket. Lambda then interrogates that S3 bucket, takes all the metadata out of that, and then dumps that into another S3 bucket. That metadata is read by our web application and points back to where our S3. That whole process is automated, one function. Suddenly we're getting these 6 copies, there's different definitions and sizes of the video, and it's available. So that's a really simple way. We have really high utilization within our platform, and we don't pay for unused resources. You use exactly what you need. So really, the last one from me is try new things. Don't be afraid of Lambda. It's not hard. Node.js is another story, but it's got Python and Java, so use what's comfortable. You're never going to see the benefit of it if you don't try. It's easy. AWS have a ridiculous free tier. It's like 1 million calls a month. We haven't hit 1% utilization on it yet, which is awesome. And they have CloudFormation scripts, so if you ever go over it, just get a new AWS account and deploy again. Not that we would do that. Yeah, so it's not all sunshine and roses. So one of our big challenges is atomic transactions. If you're doing transactions in the browser, you can lose connection, you can go into tunnel, whatever. So if you want atomic transactions, don't do them on the front end, do them on the back end in a Lambda function. Data analytics is kind of fun for us. It's our next project. So we've got all these different platforms. We've got Firebase, we've got Intercom, Auth0, Stripe has payment details, customer details. Today we're struggling to get that one consolidated view of how our users interact with our platform. So our next fun thing is building an analytics platform using Lambda, DynamoDB and Redshift to actually do that. And QuickSight will be really useful if AWS can give me access on the preview, please. Native apps, so iOS apps. Some of the stuff, if you're doing something on the web, there's lots of libraries and JavaScript libraries. Some of these applications don't have all the libraries you need. They all have JavaScript libraries, but if you're doing iOS, they don't necessarily Swift libraries or Objective-C libraries or Java libraries necessarily. So that can sometimes be a challenge. And there's some business dependencies. It's one of those strange things you've got to look at. When you go to our site and you use Auth0 to authenticate, you're using the Auth0 web page. You're actually accepting Auth0's privacy terms. When you put your payment details into Stripe, you actually accept Stripe's privacy terms. When we put your details into Intercom, by proxy, you're actually accepting Intercom's privacy terms. So we've kind of got that in our privacy statement. But that's a weird thing. You actually have to be quite relevant of that. So if you are really conscious, and you just have to be aware from a regulatory perspective, we're not in a very regulated area, and we only keep email addresses. So we don't have your phone numbers or anything else like that. So we have very low PII requirements. That's something you have to be really aware of depending on what regime you're working in, if you're going to be using lots of third-party services. But the benefits, it's one of the big questions we get is, AWS has all these services that they only have, and there's lock-in, and you can't move your Lambda function anywhere else. Well, so what? It's really fast to continuously innovate. So we've launched 2 iterations of our platform, considering it went live end of March. A third one's coming out next month. So there'll be 3 refactors in 3 months. We're adding new features almost on a daily basis. Rapid time to market. The MVP of our platform took 20 days, from zero, no code, to live, accepting transactions, 20 days. You can't do that in a monolithic world. You cannot do that in a world where you have to deploy servers and configure networks. All that stuff that doesn't differentiate your business gets in the way, and it stops you delivering value. So if you want to use Lambda, don't talk about the cost. It is ridiculously cheap. Talk about the time to value, because it's almost unbeatable in the market. And the other thing, it makes complex workloads simple. That transcoding pipeline, if we were transcoding multiple videos at once and we had to do it manually, it's really hard. We do that in about 60 lines of code, that whole transcoding workflow. It is literally 60 lines of code. It's because you don't have to worry about scaling. You don't have to worry about a lot of the stuff you have to worry when you're deploying your own servers. So that's pretty much it for me. I hope that was useful.
Hi, I'm Paul from NorCloud. I'm Country Manager for the UK business. Welcome to the AWS User Group UK's reInvent Recap Meetup. We hope that you enjoy this selection of videos. NorCloud is an AWS Premier Consulting Partner, helping organizations, whether they be startups or enterprises, with their journey into the cloud.